Alright, here is our second Khan Academy unit test. This one is displaying and describing quantitative data. This one's probably going to go by a little bit quicker, so here we go. There are 2 data points with 9. There are 3 data points with 10, 2 with 11, 2 with 12. Onward. Up next. Wow, they're really making this easy. Let's see here. How many are there from 0 to 20? None. How many are there from 20 to 40? None. How many are there from 40 to 60? 1. How many are there from 60 to 80? There is 1, 2, 3. And at this point, well, there are 1, 2, 3, 4, 5, 6, 7, 8. So since I've already used up 4, there must be 4 left over in this category. All right. Up next, Chad recorded the result of 600 rolls of a single 6-sided dice. Maybe this is what you're doing also to pass the time. And so, Chad's description of the distribution is that it is fairly uniform. The results vary from 1 to 6 and are centered around 3.5 without any outliers. And then it says which component is missing from Chad's description. Now that being said, rather than dissecting this description, you should be asking yourself all the time, what is a good description? Because a common free response question, and remember this exam is only free response, is to describe a data distribution. When you do that, there's a little acronym that people use, and it's called GSOCS. And what it stands for is gaps. So are there any gaps in the data? In this, there are not. They then talk about the spread, usually. Actually, next they talk about the shape. And the shape is usually skew right, skew left, unimodal, bimodal, or uniform is another one. Uniform means they're all almost the same. And so let's see here, outliers are next. So they did talk about outliers. Now, if there aren't any outliers, then there aren't going to be any gaps, because typically one way you start to say there could be outliers is if you notice one data point that's really far away from the rest of the data points clustered together. So if there's no gap, or rather if you don't see any outliers, you might not need to mention a gap. So we'll give them credit there. Up next, you always want to talk about the center. The center refers to either the mean or the median, and they do say it's centered around 3.5. That really is the average if you think about it, or the median really. And then also the last one is spread, and that refers to the range of data. Now, when you talk about the spread, you could talk about the interquartile range or the overall range, and they're definitely doing that here. So I don't think anything is missing from the description. All right. Up next, it says, what is the most frequent number of players at the table? Clearly, the answer is 3. Up next, we have a stem and leaf plot. Now, I have seen questions in the past on an AP exam where they ask you to make your own stem and leaf plot. Just be careful about that. And it says, what was the largest number of pair of boots in any one department store? The answer is 40, because the way you read a stem and leaf plot is this is 17, this is 18, 20, 25, 28, 34, 34, 37, 38, and 40. This is the tens place, this is the ones place, and you can see that from the key they give right there. How many houses are on Prince Street? Well, we just have to add the heights of the bars. Number of houses is right here, so 4 plus 7 plus 9 plus 4 plus 1. I think it's 25, but I'm counting really quick. We'll see. Yep. Up next, what is the shape of this distribution? I would say this is approximately symmetrical. All right? It is symmetrical and unimodal. That's another way of saying it. But it's approximately symmetrical. One thing you don't want to say is you don't want to say it's approximately normal in this case, because You just kind of don't if it's a random graph that they aren't talking about normal distributions later in the problem. So you just want to say approximately symmetrical or roughly symmetrical. All right, we're doing great. It says, at the Olympic Games, many events have several rounds of competition. One of these events is men's 100-meter backstroke. The upper dot plot shows the top 8 finishers in the 2012 Olympics, and the lower dot plot shows the times of the same 8 swimmers, but in the semi-final round. Which pieces of information can be gathered from these dot plots? One thing just to kind of think about, always think about what your data is. We're talking about swimmers right now, and it is better if the time is less. I mean, I don't know if that's going to come up in the problem, but just kind of keep that in mind. The person who did the best is this person right here, because a faster swim time means you finished before everyone else. Anywho, let's choose the answers that apply. The swimmers had faster times on average in the final round. Again, average means if you were to have all of these values be weights on a scale based on only this scale, where would you put kind of the balance so that everything was uniform? And I think I'd end up putting it somewhere around here. But for this scale, if I wanted to balance this out, I'd have to put it somewhere around here. So do the swimmers have faster times, shorter times on average in the final round? Yes, the balance point is further left, less than over here. The times in the final round vary noticeably more. Definitely true. This one has a range of 56 to almost 58, but this one only has a range of 58 to around almost 58. Sorry, 50, I was miscounting, 56 to 58, and then this one's almost like 56.75 to 75.75. So this one ranges by almost about 2, this one ranges almost by about 1. Oh, last but not least, it's 1, 4, 2, 2, and 1. And this would be a skew left distribution. There's more data to the right, and you'd kind of draw it like that. Skew left. And we're done.